This tool calibrates petrophysical-derived porosities, or PHIE, in order to optimize permeability prediction. PHIE represents the average porosity over a depth interval, which is determined by the reading interval of the wireline log tool. Averaging the porosity does not affect the overall porosity, but may have a severe effect on permeability prediction and flow properties. Permeability is usually predicted from porosity-permeability transforms based on core plug measurements, and these represent spot measurements. Plug-derived porosities, or helium porosity, show a wider range than porosities derived from wireline logs, because the spikes are lost in the PHIE averaging process. In a helium porosity versus PHIE crossplot, the helium porosity therefore often show higher values in the higher porosity ranges, and lower values in the lower porosity ranges, as compared to PHIE. The use of petrophysical average porosities implies the prediction of average permeabilities, and interval averages are compared to spot measured data. The flow properties in a reservoir is usually not controlled by an average permeability, but rather by laterally continuous high permeable pathways represented by the high porosity spikes. Uncalibrated PHIE values therefore tend to underestimate permeability and flow properties in the reservoir. The current tool is a method for calibrating PHIE to measured helium porosities so that the high permeable pathways are better represented in the dataset. Permeability prediction based on porosity-permeability transforms after PHIE calibration is believed to better represent flow properties within the reservoir. Permeability predictions based on porosities derived from wireline logs should therefore be carried out on the adjusted porosities and using porosity-permeability transforms for core plug data. The tool can only be carried out on multi-data sets and is therefore only available to licensed premium subscribers. A demo version is, however, available with a standard subscription. Let us take a look at the licensed version. A valid licensed company name has to be entered into the text box. We then press the Go button. The Multidata Entry tool opens in a new tab in your web browser. The first worksheet gives some introductory instructions. The tool consists of two parts given by the worksheet's Prediction Tools and Prediction New Data. The latter worksheet is optional. Let us go to the Prediction Tool worksheet. In this worksheet, plug-measured helium porosities and PHIE are compared in order to calibrate PHIE to optimally fit the helium porosities. The PHIE values are optimized by increasing the PHIE values in intervals where porosities are underestimated as compared to helium porosities, and lowering PHIE in intervals where porosities are overestimated. This will give improved permeability prediction using PHIE in porosity-permeability transforms. Input data cells have a yellow background color, whereas the prediction data normally are given in cells with green background. Only yellow cells can be edited, all other cells are locked. We first enter or paste data into columns A to C. Data entries into column A is optional. Results are presented as calibrated PHIE values in column D, As a quality control, average helium PHIE and calibrated PHIE porosities are given in cells G2, I2 and K2. The average porosities should only show minor differences. The upper plot shows the unadjusted dataset where the helium porosity and PHIE are cross-plotted. The lower plot uses the black trend line equation from the upper plot and calibrates the PHIE data. This optimizes the PHIE to helium porosity calibration in such a way that the black regression line approximates the red 1-to-1 line. The calibration has no effect on the R-squared value and minimal effect on average porosities. Please note that depth-shifted helium porosities should be applied in column B. Furthermore, PHIE and helium porosities should have common depth points. Please note that helium porosities and corrected PHIE are in percent, whereas PHIE are in fraction. The second part of the tool, represented by the Prediction New Data worksheet, is optional. The results from the previous worksheet can be applied to uncored intervals of the well and/or to other wells in the field, given that the depositional system is the same as for the input data in the previous worksheet. Data are entered into column B and optionally into column A. The calibrated porosity, which should be used for permeability prediction, is given in column C. As a quality control, average PHIE and calibrated PHIE are given in cells E2 and G2 respectively.